Welcome everyone. So today we're going to be talking about the best practices for Citrix workloads on XenServer and some optimizations for Citrix only available from XenServer. So for presenters, we have Ian Firth, a product manager at XenServer, and Alex Brett, a chief engineer at XenServer. So Ian, I will hand it over to you to kick things off.
Okay, let's get going. We're going to talk about the challenges of running end-user compute workloads on virtualized platforms, and specifically two of the big ones that we often see customers asking us about. The first of these is around capacity and performance and managing those in balance with each other. So you can plan for day to day, and that's great, but what happens when you get that unexpected workload or you need to scale or expand? I'm going to have a bit of a peek at the use case, and then I'm going to let Alex dive in with some more technical details on these things. So let's look at this use case. You've deployed your network and your storage, and it's all running normally. You know, VMs are starting and stopping all independently over time, and the load's sped nicely across all of your hypervisor hosts. The EUC workloads are really dynamic. They start and stop all of the time. So this is a really common scenario. But everything is working. It's great. It's well within tolerances. But what happens when you take a host out of service and you bring it back up and all those VMs start up again? Or there's an unexpected load. I mean, maybe HR decide they're going to run a training course at 9 o'clock in the morning and everybody logs in at the same time and lots of VMs spin up at the same time. Or all of your workload has been updated with some really important security update and they all need to reboot. They're all going to do that at the same time. Or, someone's come along with a new use case, or a new department's joining, or some new members of a team are joining, and you need to create, 10, 100, 1,000 more VMs. Now you've got an issue. All this load is now going to be reading and booting over the same networks, using the same storage, all at the same time. So have you got enough capacity now? Well, I suspect the answer is no. You're going to saturate it at some point. And it's really hard to predict how big this extra load is. You can't really just over provision enough. And if this does happen, at best, things are just going to take a while to boot. Maybe end users are going to ring up the help desk and say, why can't I access my compute? And after time, it'll settle down and back to normal, and you can breathe a sigh of relief. At worst, not only do the VMs maybe not boot, and the workload doesn't come up at all, and you've got to re-image things and rebuild compute to make it work, but maybe there are other business processes that share the same networks and storage as these VMs, which also get impacted. So this could be a big challenge. So do you size for that worst case, spend loads and loads of dollars, never really knowing if you've over-provisioned enough storage and network to cope with the situation, so it'll happen anyway? Or just hope when it does happen, you can cope with it, because it will happen. Or maybe there is another option. What if you could do neither? What if you could get predictable and lower bandwidth usage within all of those scenarios, and maybe gain some advantages like things booting up faster along the way? Well, let me hand over to Alex and see if that's something he can actually make a possibility.
Okay, thank you. First thing I'm going to talk about is PVS Accelerator. So for those unfamiliar, Provisioning Services, or PVS, is a Citrix technology that essentially allows you to boot VMs over a network and run them. Of course it does far more than that, but that's a sufficient description for today. Normally, if you're using PVS with any hypervisor, every VM is going to make a network connection to the PVS farm to stream all the disk data that it needs. Clearly, that's a lot of connections, and potentially a lot of data going over your network and heavy load on your PVS farm, particularly in some of the scenarios Ian described where you start lots of VMs at around the same time. What we do with PVS Accelerator is we've got the same situation, but we've got this thing called the accelerator running on each of the hosts. The result of this is you effectively only have a single connection from each host to the farm. The accelerator then caches a large amount of the data required, significantly reducing your network traffic and load on the PVS farm. So how does this actually work? Well, let's first look at the situation without the accelerator, and this is going to be common for most hypervisors. You've got a virtual machine, may or may not have a write cache disk available, and it's got a network connection through some sort of virtual network switch to the PVS server. PVS Accelerator then runs on the host and operates with either a memory cache or a disk cache, and it has a cache manager to handle that. We then hook this in via a packet filter, which sits inside the virtual switch. This intercepts packets going between the VM and the PVS server and sends them through the accelerator. Most of the messages just get passed straight through and the accelerator doesn't do anything to them. However, for any read requests, it will first see if it can serve that from its cache. If not, it'll pass it through, but it will then cache the resulting data as it comes back from the PVS server. So it basically acts as a transparent proxy. The cache understands PVS, so the result means if you boot a large number of VMs from the same image, they can all benefit from the cache, and the data is only ever fetched once rather than by however many VMs are running on the host. So let's now take a look at what this looks like in practice.
Okay, so what you're seeing here on the left is us booting 5 virtual machines that have all been provisioned with PVS without using the PVS accelerator. And you can see that the dial in the right hand side, which is showing the network throughput, is going up to well into the hundreds of megabytes per second as those machines boot, and it's there's a continuous throughput of network load there right the way through to the machine completing their boot. And here's a graph of the CPU and network usage that you can see for that particular boot cycle. Now if you look on the right hand side of the screen, we're going to boot those same 5 machines for the first time after the PVS accelerator has been enabled. You can see again the dial in the top right is showing network throughput, and you'll see there's still some network throughput there, but it's not as high as it was before, as only really the first time a block is being read is it being read across the network. After that's served in the cache, and you can see here that the boot time is less and the load over that time was less. So now if we boot them again, this time they've obviously all been cached already by the first boot. You can see that the network dial in the right almost looks like it's broken, it doesn't move at all, because this time the blocks are being served completely from the cache and memory, and as a result you will see that there is a lot less load on the network and CPU, and the boot time is even less than before. So this kind of shows and demonstrates that the network is being used an awful lot less, as it's being served more and more from the memory cache that Alex has talked about, and you can see the impact of that on the ability to speed up boot times. So I think that's a really good, effective demonstration of what might be possible.
Okay, so that was the PVS accelerator, which we've looked at, and it's great for network boot VMs, but what if you're not doing that? What if you're running VMs on some sort of shared storage? So, for example, using Citrix Machine Creation Services or MCS. In this case, we have a technology called IntelliCache, which lets you use local storage on each host as a cache for the network storage. So we've got a familiar looking diagram here. In the normal case, each VM is making its storage requests to or from some sort of shared storage device. Could be NFS, iSCSI, Fibre Channel, doesn't really matter. The result is, as with the sort of network case, you might have some high storage traffic and heavy load on your shared storage in the scenario where you boot lots of VMs at the same time. What we do with IntelliCache, though, is we change this. You can sort of think of it as us routing the storage traffic through a cache, which uses local storage on each host to cache data, thus reducing the amount of storage traffic and the load on the shared storage device. So how does this one actually work? Well, as I've mentioned, it uses local storage as a cache for any network storage, except currently GFS2, and it can cache both the base or gold image and any VM differencing disks, and importantly, it can cache writes as well as reads, which can significantly increase the benefit. There's 2 main use cases. The first is for persistent VMs. This is where you need the VM to persist long term, so perhaps a dedicated desktop for an end user or something like that. In this case, any writes the VM may do, which are the blue lines in the diagram, are sent to both the differencing disk on the shared storage and a cache version on the local storage. This means that when we come to do a read, we can first see if the data is present in the local difference cache. If it is, we serve it from there. If not, we check if it's present on the shared storage differencing disk, and if so, we'll serve it from there and cache it in the process. If it's not on the remote differencing disk either, so something that hasn't changed from the base image, we can check our local cache of the base image, and if it's there, we return it. If not, we'll go to the remote base image, and again, we'll cache that in the process, and we return the data from there. It's important to note here that any caching that's done here, all the lookups for this are done with, we know where the data is, we don't have to actually route every block all the way through all those 4 cases, we know where to go immediately. The other thing to mention is that in this scenario, the VM is still agile. You can migrate it to another host. If you do, you might have an empty local differencing cache, but that will build up again as more reads and writes occur. The other use case is the non-persistent use case. This might be a desktop image that you want to reset on every boot. In this scenario, we can make things even more efficient. This is because we can now send writes only to the local differencing cache, as we don't need to persist them long term. It does mean the VM's no longer agile, it'll be tied to the host it's currently running on, but this can make a massive load reduction on shared storage devices. Reads work in a very similar way to the persistent case, except we don't need to check the remote differencing disk anymore. So the end result in this is if you're going to boot a large number of identical non-persistent VMs, after the base cache has populated from the first few boots, you can end up with basically zero load on your shared storage, as everything is being served or stored in local caches. The final optimization I'm going to talk about is called read caching. This is available when using a file-based storage repository, so NFS, SMB or GFS2, and it's enabled by default. It caches data being read from storage into spare memory in the control domain of the host. This does mean that the performance improvements depend on the amount of free memory in the control domain, but you can always increase the control domain memory to give more cache space if you need to. It does only cache reads, so it's primarily useful for base or gold images. However, it can be used simultaneously with either IntelliCache or MCS storage optimizations, or both, which for those not familiar, MCS.io provides a mechanism to offload writes to another storage tier. These technologies therefore are complementary to each other, and if you combine them, you can get a very optimized caching solution.
Okay, so that covers the capacity and performance management section. I just wanted to add to that all the things that Alex talked about are very easy to use. There's minimum configuration to make, and the Citrix provisioning tools that are provided either through Web Studio or the PVS tools have all of these functions integrated in them. So it's just a question of ticking a box and away it goes. So it's very easy to use. Okay, so let's look at upgrade and patching management challenges. Security disclosures are happening faster and faster, and I don't think there's any of us would disagree that that's not going to get even faster still. But along with those disclosures come patches that to solve those problems, and there are bug fix patches and new features to gain. So we'd like to, keep going along and keep things moving forwards as fast and easily as possible. But this kind of conflicts with the fear of upgrade causing issues. More outages that you weren't expecting as part of that process, that you need to solve through the day or through the night to get things back up and running as fast as possible. So I think it's fair to say that hypervisor updates are complex. And it isn't just because of the quantity of hosts and their interconnect and network and storage, but it's because of that implicit link to the end user applications and the risk of disruption to those and the day-to-day work of the employees. So this kind of brings the need for outages. And often the linkage between the hypervisor update and the workload they're providing is unknown or unclear. And this produces business risks that mean that you need a planned outage. Those planned outages, because of the risks and the fears, tend to need a lot of planning. And a lot of planning means a lot of elapsed time. And a lot of elapsed time getting those fixes in place is a bit of a problem, especially if there's security issues. But it also means that quite often, by the time you've got one set of patches ready to go, there's another set already queued up, and it becomes a continuous conveyor belt of time and effort and energy spent keeping these patches and service up to date. And all this brings, additional workload on top of the things that you're trying to do, and anxiety and stress, and probably overtime, probably unpaid. So what if you could reduce that stress and the overheads associated with it and break that cycle of fear, keeping everything up to date with lower overheads and minimum outages? Again, I think that'd be a good time for me to challenge you, Alex, to see what steps we can do towards improving those things.
Okay, so I'm going to take a look at some of the changes we've made in XenServer 8 in this area to try and work towards these goals. So for those not familiar, previous releases used something we called hotfixes. We'd issue a hotfix for an issue or a set of issues, and there's quite a lot of them. I think we're up to about 63 of them now on 8.2 CU1. They do the job, but they do have some downsides. Firstly, there's what we call the fallacy of choice, having all these different hotfixes. It sounds like you should just be able to pick and choose the ones you want to fix specific issues you might be having or are concerned about. However, it's not really practical for us to test every possible combination of different hotfixes. I mentioned there's 63. I'm sure you can do the math to see how many possible combinations that is. Given that, the vast majority of our testing in engineering is done with all the hotfixes applied, and that's what we'd always recommend to customers. There is also some complexity because some hotfixes will roll up other hotfixes or depend on them just because of technical constraints. What we've decided to do therefore for XenServer 8 is we're using a new model with a continuous update stream. What this means is we don't provide discrete hotfixes, but instead you just update your host to the latest state all in one go. We think there's significant benefits in keeping hosts fully up to date. In particular, you might pick up a bug fix before you encounter a bug rather than having to encounter the bug then go looking for the hotfix. And also by regularly receiving small changes rather than doing a big jump when you're trying to get a fix for a specific problem, it should mean it's easier, should there be any unexpected problems, to track down the cause of them rather than, for example, trying to work out where in 6 months worth of changes some problem came along. So how does it actually work? Well, we'll be releasing updates on approximately a 2-week cadence. You obviously don't have to apply them that frequently if you don't want to. Our support policy is currently that you must update at least every 6 months to remain supported, although we'd encourage more frequently than that. Although we'll be rolling out updates more frequently, we do intend to make more use of technologies such as our live patching solution for the hypervisor and the kernel, just to reduce the chances of requiring a host reboot. You have a choice of the early access or normal channel. Routine updates roll through early access before they reach normal, so you might want to use it with a test or a staging pool perhaps to get early sight of any changes before they reach your production pools. Some security updates or very urgent fixes might roll out to both channels simultaneously. To actually get the updates, you first synchronize them down from the CDN. This does mean your hosts need either direct or via a proxy internet access, but we have got a solution coming soon for environments that have no access at all. After the synchronization, you have an opportunity to view and assess the available updates prior to deciding to apply them. So you can take your time to review what changes there are, consider any implications for your environment. Let's just take a look at what that looks like. So there's a couple of different views of the available updates. You can view them by server or by update. You've got various categories, so you can see there's sort of security fixes, bug fixes, new features, and you get all the information available to you about what the updates are. We've also made some changes to the post-update guidance. Previously, each hotfix had a single piece of post-apply guidance, which more often than not ended up being to reboot the host. We all know that host reboots can be painful and are likely what's going to require maintenance windows or outages. So we've made some changes to try and allow you to minimize how often you have to do them. Particularly important, obviously, now we're releasing updates more frequently. To do this, what we've done is separate the actions into 3 distinct classes. The first class is what we call mandatory. These are actions you must perform, otherwise the system may fail. We expect a mandatory reboot to be extremely rare. Normally this might be a mandatory tool stack restart, something like that, which would only cause a very brief management interruption and not affect any running VMs. In XenCenter, you aren't given a choice about mandatory guidance. You have to do it in order to apply updates. The second class is recommended. These are actions that we recommend the average customer should do. If you don't, you might not get the effect or benefit of an update, but the system will continue to operate. So in XenCenter, you can choose whether you apply recommended guidance or not. The idea here is that you can review the available updates that recommend a particular action, and if you don't think they're important to you, you could choose not to do them. The final class is full effectiveness. These are actions that are required to get the full effect or benefit of an update, but we don't actively recommend most customers do so. This would be, for example, specific driver updates that might only affect rare hardware, or a very rare issue that might only happen at startup, or something like that. You can tell XenServer to carry out these actions, but by default it won't do so. You see all this guidance before you decide whether to apply any updates, so you can make an informed choice and decide if you need an outage window or anything like that. Let's just look at some examples here. So here I'm viewing a set of updates by server, and XenServer's telling me what the mandatory and recommended update tasks are for this particular set. I can also see this information by update, where you can see the different types of guidance for the different updates. And finally, when I actually come to apply these updates, I can choose whether to have it apply the recommended guidance or not. In this example, there isn't any additional full effectiveness guidance, so I've only got the choice on recommended. And yeah, so you can select things there. There is one additional consideration to mention here that affects updates, which is around pool size. This is how many hosts you group together to manage as one pool. A pool in XenServer is how we manage multiple hosts together, sharing the same storage resources and things like that. When using something like MCS, a larger pool does make it easier because you've got fewer copies of a gold image or whatever to distribute and maintain. It also can allow you to make more efficient use of your storage resources, fewer LUNs or shares to maintain. On the other side, however, it does mean that the overall time to update or upgrade a larger pool is increased, particularly if host reboots are involved. Depending on exactly what the update or upgrade entails, it may also result in an increased time where services are unavailable, so you might need a longer maintenance window. It also means with a larger pool that should there be a problem with either the pool or a supporting resource such as storage, the impact to your organisation could be higher. Ultimately, there's no one-size-fits-all answer here, but when designing a system you do need to consider these points and make a decision on what's appropriate for your specific circumstances.
So that wraps up our webinar for today on the best practices for running Citrix workloads on XenServer. I'd like to thank our presenters Alex and Ian, and to learn more head over to XenServer.com.